Hey everyone, and welcome back to this class, Artificial Intelligence, Reinforcement Learning in Python. In this lecture, we are going to start looking at the code for tic-tac-toe. Typically in machine learning, we're implementing self-contained algorithms, so it's simple to look at the code line by line. However, with reinforcement learning, there are multiple objects interacting, so we'll need to take an object-oriented approach. Because of that, we'll first do an overview in this lecture of all the objects we need to represent and how they interact. After that, we'll look at the details of each object. Keep in mind that this solution is in no way unique, and in fact there is some poor coupling between objects that are probably not optimal. So if you were to do this on your own, chances are high that your solution might look way different, which is okay as long as it works. If you don't want to code along and you just want to run the code, the relevant file is tictactoe.py. At a high level, we'll have two main objects, the agent and the environment. During any game, there will be two instances of the agent object, and they'll both interact with the same single instance of the environment. In order to make these things interact, we can create a function called playGame, which accepts the agent for player 1, the agent for player 2, and the environment object. So what should go inside the playGame function? Inside this function, it'll essentially be a single loop. We'll alternate between the two players, and at each iteration of the loop, we need to do a few things. First, we need to make the current player perform an action which updates the environment. Second, we need to switch who the current player is so that it alternates. Third, we need to check if the game is over, since that's when the loop will terminate. So you see here we've created a partial API for some instance methods that our objects will need. The environment will need a GameOver function that returns a boolean, true if the game is over, false if not. You can imagine that this is going to have to scan the board to check if there is a winner or if the board is full and it's a draw. The agent will need a takeAction function, which accepts as a parameter the environment. This will update the environment and hence the state. Another function we need on the agent is an update function that updates the agent's internal estimate of the value function. This is where the update equation we talked about is going to go. The update function will need to accept the environment as well, since it'll have to query the most current reward from the environment. Another function that will be extremely useful for us, but not strictly necessary, is a drawBoard function that will display what positions are currently occupied and by what pieces. From this design alone, you can probably start coding your own tic-tac-toe. So if you had no idea where to start previously, hopefully this gave you a direction for where to start heading. So if you want to try to do the rest yourself, that would be highly encouraged.